So in this question we have a bag that contains 10 marbles, of which 3 are orange and the rest are blue. We are told that Kate will draw one marble, so she'll take one marble out of the bag and then she'll put it back and then she'll take out a second marble. The first question says, draw a tree diagram to illustrate the above information. So a lot of people panic with tree diagrams, but I promise you they're probably one of the easiest parts of probability. So what you got to do is imagine yourself as Kate, okay? So we're going to put a little dot over here, which will mark the start of our tree diagram. Now, if you were Kate and you walk up to that bag for the very first time, you have, okay, now let's say you're not looking in the bag. So you stick your hand into the bag and you choose something. What are the two possible outcomes? You could either pull out a blue marble or you could pull out an orange. Now, of course, you could go draw 7 blue arrows and you could go draw 3 orange ones, so you'd have a total of 10 arrows, but that's complicated. What we rather do is the following. We will say that the probability of a blue, well, out of a total of 10, 7 of them were blue, and out of a total of 10, our chances of getting an orange were 3. Now you have to imagine which one. So let's imagine that Kate chose blue. Okay, so she's gone this way. Now you completely forget about this part. We'll get back to that later. So now Kate is okay, so she's taken that marble out. She's put it back, and now she's about to do her second attempt. So when she puts her hand into the bag now, what are her possibilities? Well, once again, she could draw a blue, or, of course, she could draw orange. And her probability, well, for the blue, well, there's still 10 marbles left in the bag because she put the other one back, and so there's still going to be 7 blue ones, and the probability for orange would still be 3 out of 10. If, however, and we'll look at this in a future question, Kate did not put the other marble back, then there would only be 9 marbles left and we would have to change things up a bit. Now let's imagine instead that Kate went down this path the very first time. Well, then when she does her next draw, these are her two possibilities. And once again, the possibilities or the probabilities would be 7 out of 10 and 3 out of 10. Now that everything's complete, we need to look at the different combinations. So if Kate did this, that would be a blue marble and another blue marble. So I'm going to call this the blue-blue branch. Likewise, this will be the blue-orange branch. This would be the orange-blue, and this would be the orange-orange. So now the next question says, determine the probability that Kate draws 2 orange marbles. Okay, so her first one is 3 out of 10, and the next one is 3 out of 10. So, what would go in between that? Would you say or would it be and? Does she draw an orange or another orange, or does she draw an orange and another orange? Well, she draws an orange and another orange, and so we're going to multiply over here. If it was or, then we would use the or formula. Remember, we looked at this in one of our previous videos, that if it says and, you have to multiply. If it's or, you plus. So to memorize this, whenever you work on a tree diagram question, to work out the probability of a specific branch, you multiply. And so if we had to multiply these now, we would get a total of 9 over 100. Number 3, determine the probability that Kate draws 2 blue marbles. So that's the BB branch. So that's 7 over 100 multiplied, not 100, 7 over 10, sorry. So it's that one multiplied by this one, which is 7 over 10. And that's going to give us 49 out of 100. So her chances of getting 2 blues is 49%, and her chances of getting 2 oranges was 0.09, so it was 9 over 100, which is about 9%. So her chances of drawing 2 blues are much higher, and that makes sense because there's more blues in the bag than orange. Number 3, determine the probability that Kate draws a blue marble. Well, that's quite a lot to ask. A blue marble could be any one of the following branches. This one, because that's BB, so that's blue, blue. She could do this one, which is the blue, orange. Or she could do that one, that's the orange, blue. So we would have to go add all of those together. Okay, so let's do that, and then I'll show you a faster way. So we already know the BB, the blue-blue branch, that's 49 over 100. Let's quickly work out the blue-orange branch, which is this one. Well, that's going to be 7 over 10 times by 3 over 10, which is 21 over 100. Next, we could look at the orange-blue, where that will be 21 over 100. And then for the last one, which was the orange-orange, we already said that that's 9 over 100. Oh no, but we don't want that one anyway, so we only want those first three. Now what's very important is that when you take these three values now we can add. You don't have to you mustn't multiply these. These ones you are actually going to add together. And that gives us a 91 out of 100 chance. And that's 91%. Now that makes sense. Imagine you, Kate, and you busy drawing marbles out of a bag, and you do this twice. The chances that you get a blue are going to be pretty high. I mean, there's 77 marbles are blue and only 3 are orange. So you have a 91% chance that you would get at least one blue. So Kevin, you mentioned that there was a faster way to do this. Well, yes, we know that if you had, the way it works in probability is that if you have to add each of these different branches together, which is all the total outcomes, you should get 100 over 100, which is 1, or 100%. Okay, because if you complete everything, it always equals 100%. For example, if we have Venn diagrams, and let's say those two circles completely give us 65%, then on the outside we would have 35%, because we always have to end up with 100% if we're busy with percentages, or 1 if we're busy with probability fractions. So instead of adding this whole branch plus this whole branch plus this whole branch, why don't we just do this? Why don't we just calculate this branch, which is 9 over 100, and then just say, or that equals 0.09. Now we know that all of the probability should add up to 1. So we could say 1 minus that branch, which is 0.09, and that gives us 0.91, which is the same as 91 over 100, which is what we got over here. So instead of calculating 3 different branches, we only calculated 1, and then just subtract. So let me explain that once more. All 4 of those branches should add up to 1, which is 100 over 100. The bottom branch is 9 out of 100. So if that's 9 out of 100, then it means that these 3 branches over here should give us 91 out of 100. Next question says, determine the probability that Kate draws at least one orange. So at least one orange, well, that means one orange or more. So that would be this branch and this one and this one. Because remember, the word at least means that or more. So you can have more. So once again, we could go add each of these together, which would give us 51 out of 100. Or, because we know that these 4 branches should equal 100 over 100, then we could just say 100 over 100 minus this one over here, and that also gives us 51 over 100. So whichever way is best for you.